In this assignment, we will begin work on the lift by creating a set of double doors. The lift will have inner and outer doors, and the inner doors will track the motion of the outer doors. Here, we will set up the motion of the outer doors and write code that will apply to the lift's inner doors that we will add in the next assignment. The double doors of the lift will work in a similar way to the single doors we have already made, but with some subtle differences. We will start, as before, by dragging the model into the scene. In the Models folder, locate Door Exit Outer and drag it into the scene view. Position it at -22, 0, 46, and rotate it by 270 in the Y-axis. Double-click its name in the hierarchy to focus the scene view on it. You should now see that it's located inside the lift shaft. Before we go any further, let's enable light probes on both the left and right door so that they are affected by the lighting in our scene. Open the hierarchy and select both doors, then under the Mesh Renderer component, check Use Light Probes. Next, as with our single door, we need to add box colliders to each of the doors and a sphere trigger collider to the parent object. Select the parent object and choose Add Component, Physics, Sphere Collider, and check the Is Trigger box. Then select both child door objects and choose Add Component, Physics, Box Collider. We want the proportions and the position of the trigger collider to be slightly different to the single doors. This is because we want the doors to shut behind the player character when they enter the lift. Reselect the parent object, and in the Sphere Collider component, set the center to -1, 1, 0, and set the radius to 2. Now we need to create an animator controller asset to control the double doors. It should be exactly the same as the single door animator controller, but with the animations for the double doors instead. As such, we can duplicate the single door animator that we made earlier and rename the duplicate to Double Door Animator. Open the Animators folder in the Project panel and duplicate the single door animator. You can use the shortcut Command-D or Control-D on PC, or go to Edit, Duplicate. Then rename this Double Door Animator. Now all we need to do is edit the animations that the states represent. Ensure that you can see your animator window, and then change the single door open animation to the double door open animation, and likewise for the closed. To do this, select the open state in the animator window, and then in the Models folder in the Project panel, expand the Door Exit Outer FBX so that you can see the open and closed animations beneath it. Drop the Door Exit Outer Open animation onto the Motion field in the inspector for the open state. Then select the closed state and drag Door Exit Outer Closed to the Motion field for this state. We can now apply the animator controller to the animator component. Reselect Door Exit Outer in the hierarchy and drag the double door animator from the Animators folder in the project to the controller property of the animator component. We also need to make sure that root motion is not applied, so uncheck this box. As with the single doors, we need to add a kinematic rigid body component to the moving parts. Select both the Exit Outer left and right doors, and go to Add Component, Physics, Rigid Body. Uncheck Use Gravity, and check Is Kinematic. Now we can apply the door animation script that we wrote earlier to the parent object. Select Door Exit Outer, and then in the Scripts folder, under Level Dynamics, drag and drop door animation either into the inspector beneath the other components or onto the name of the object in the hierarchy. We need to make sure that the correct audio clips are applied. So in the Audio folder, drag and drop Door Open to Door Swish Clip, and Door Access Denied to Access Denied Clip, and also that this door requires a key by checking the Require Key public variable in the inspector. As with the single doors, for these doors we will need to add an audio source component and make sure that Play on Awake is unchecked. Click Add Component and choose Audio, Audio Source, and uncheck Play on Awake. The doors are now ready to be stored as a prefab. Do so by dragging the parent object from the hierarchy into the prefabs folder in the project panel. The last thing we will do in this assignment is to make a script that will make the inner doors of the lift move with the outer doors that we have just made. We will call it Lift Doors Tracking. However, we are not going to apply it to the doors. Instead, we will be applying it to the lift that we will make later. Select the Scripts folder in the project panel, and then select Level Dynamics. Click Create and choose C# script. Name the script Lift Doors Tracking. Launch the script for editing, and then prepare it as usual. In this script, we are going to make the inner doors lag just slightly behind the outer doors. As such, we will need a variable that we can tweak for how fast the inner doors will catch up. We will set this to a default of 7. We also need to store the transform of each of our doors. The last class variables we will need are floats, in which we can store the X component of the position the doors are in when they are closed. We will use this to force them to close when the lift is about to leave. Next, we can use the awake function to allocate our references. We are going to use GameObject.find rather than tagging each door separately. At this point, it becomes obvious why a strong naming convention is advised. We know that our double doors have names like Door Exit Outer Left 1. Using our naming convention, we know that the inner doors, those attached to the lift, will be named Door Exit Inner Left 1 for the left, and likewise for the right. We also need to set the closed X positions. Since the doors will start off closed, we can set up these variables in the awake function. We need a function that will move the doors based on a target X coordinate. We will need a float argument for each of the left and right doors that will be passed to this function when it is called. We will call this function moveDoors. Normally, when we want to smoothly transition from one position to another, we'd use vector3.lerp and therefore modify the x, y, and z coordinates. But since we want the inner doors to also move up with the lift, we're only going to lerp their x coordinate using mathf.lerp. We'll then simply pass in the existing y and z coordinates into the vector3 for the new position. We will use this mathf.lerp on a new float variable. Firstly, we will set the left inner door. We then set the position of the door to a vector3 with the newly offset x coordinate and the existing y and z coordinates. Next, we can reassign this new x variable for the right inner door's new x coordinate. And with this, we can set the right inner door's position. With that function complete, we need a couple of ways of calling it. Both these functions should be public since they will be called from the lift triggering script that we will write later. We need one function to call the moveDoors function with the parameter of the outer door's x positions so that the inner doors will follow them. The other function we will need will call moveDoors with the parameters of the closed x positions for when the player is inside the lift, and it must close to seal them inside. We will start with the function that makes the inner doors follow the outer doors. We will call this doorFollowing. All we need to do in this function is to call moveDoors with the outer door's x positions as parameters. Next, we will make the function closeDoors, which will call moveDoors with the closed x coordinates. The script is now finished, and in the next assignment we will attach it to the lift. For now, save your script and return to the editor. Remember to save your scene and save your project. In the next assignment, we will be finishing off this chapter by creating the lift through which the player completes the level.